Research and development plays a central role in advanced economies. It's important to economic growth, job creation, industrial competitiveness, national security, all kinds of areas like agriculture, transportation, public health, environmental protection, et cetera, and of course it expands just human knowledge in general. After World War II, we've talked about this in other classes, after World War II, the United States was really the global powerhouse. And the United States, as you can see by this slide, was really investing heavily in global R&D and was investing much more than the rest of the world at that time. However, as you can see in the pie chart on the right, that has really flip-flopped. And it's actually not that the U.S. is investing less. In fact, the U.S. continues to fund R&D pretty robustly, but the rest of the world has increased its investments even more. So we shouldn't look at this as necessarily a bad thing. It's just an indication that the rest of the world has realized the importance of investing in R&D and is doing so much more robustly. This chart reflects R&D spending, globally speaking, broken down by country, and the numbers reflect a total of grants, licensing, money from crowdsourcing, and company resources. And you can see that globally speaking, R&D spending has almost tripled since the year 2000 until present day. We can see that a lot of that increase was driven by China. China was very low in R&D spending in the year 2000, and then they have really shot up. And as we can see, if they continue on this trajectory, they will pass the U.S. in spending in a couple of years. And we can see that that's giving rise to the growth of companies like Huawei, and there will be increased competition from China and from other emerging economies as they continue to invest in R&D. Okay, so on your piece of paper, take a moment out to do lecture activity 12.3, answering true or false to each of the following 3 questions. Property rights are important to understand, especially intellectual property rights. Before we get to intellectual property, I just wanted to spend a moment on property rights in general. So property rights are defined as the authority to determine how a resource or economic good is owned and used. So it's a means of deriving benefit from an asset that you own. So property rights are a social and legal construct, and that means that they're protected by some laws, but also they're socially accepted. So this idea that I own this particular car, I own my car, I have real property and it is my car. And that is a socially accepted construct, and it's legally enforced because I have a title to my car. So that's the next point. There's often some documentation, especially on large assets. You might own the deed to your home, you might have title to your car, or in the case of machinery and equipment, you might just have some kind of contract or something that proves that you own this asset. So property rights can be divided into 2 broad categories. There's real property, like your house, and that's, or your car, something like that. And then there's intellectual property. And intellectual property, globally speaking, is a much bigger challenge, because while it's easy enough to get a title on your car, it's much more difficult to prove that you own an idea or an invention or something that you made up. The property rights we just talked about are important to economic growth. And while it's one thing to have a title to an automobile, It's much harder to demonstrate title or something like that to an idea. And this has been a big discouragement to innovation, globally speaking, because why go through the effort and energy of inventing something just to have it ripped off or pirated or knocked off by another country? Usually, that historically speaking, that's often been China. And so globally, the powers that be felt that there needed to be something done about this. And so what they came up with was an agreement called TRIPS. And TRIPS stands for Trade-Related Aspects of Intellectual Property. And it was an attempt to bring conformity to national systems of patents and other protections for intellectual property. So TRIPS came out of the Uruguay round of the WTO, and it is considered a real success of the WTO. It sets out some minimum standards for protection of intellectual property across the globe, and it attempts to standardize protections between different countries. It also provides some standards for enforcement and suggests that parties can use the WTO trade settlement process, dispute settlement process, to settle intellectual property disputes. TRIPS, was really a major milestone, especially against or to help with countries like China, who are historically accused of pirating a lot of inventions. And so that was why we saw how many more patents China is filing now. This whole idea of intellectual property protection is very new to China, but the Chinese have embraced it because there's been problems in China of Chinese ripping off their own technology. Hopefully TRIPS is helping. Technology diffusion refers to the way in which technology moves around the globe. And so we know that over the years we now have freer trade. I'm not going to say we have free trade because we kind of have managed trade, but it is certainly freer and we're more interconnected, and that has helped with technology diffusion. FDI and tech transfer, whether it's forced or not, helps with technology diffusion too. And what I mean by forced tech transfer, again, to use China as an example, historically speaking, if a U.S. company entered into a joint venture with a Chinese partner, it might be forced by the terms of its contract to provide its technology to its joint venture partner. So China gained a lot of technology through forced tech transfer. Technology is also able to diffuse more now that we have stronger intellectual property protection guidelines that we just talked about. Because of technology diffusion is a good thing. It's not all about stealing technology. There are positive network effects. So for example, I can see some other country's invention, and then that might prompt me to invent yet something else, building on that invention. Many countries, and China's a good example, go through this process of adoption, adaptation, and invention. So first, they will just adopt another country's technology. A little further down the development path, they might adapt that technology to their own market. And then the final step, and this is where China has arrived at today, they finally move from imitation to inventing their own product and really adding knowledge to the world's store of knowledge, which is a good thing. And technology diffusion improves productivity. But in order for all this to work, you need good infrastructure, you need some funding sources, you need skilled labor, and you need some organizational practices that are able to capitalize on the technology as it's diffused. So technology diffusion is the way that technology spreads. Technology transfer is some kind of deliberate action that transfers knowledge from one company or one country to another. Technology can diffuse through specific channels, and I'll touch on a few of those. So foreign direct investment can have something called a spillover effect. So spillover effects benefit the host country. So spillover effects might be something like, if I'm Apple and I do business with Foxconn, now all the employees in that particular factory know how to make Apple products, and they've been trained in those areas. So those employees now can go forth and start their own companies or go work for other companies. So in that way, technology is diffused. International collaboration through joint ventures, strategic alliances, etc., can also spread technology. So for example, in my Apple example, if I do a joint venture with a local Chinese company, that Chinese company now knows how I make my products. Supply chains are another good way that technology is diffused. Again, your suppliers know a part of your production process, so that can provide technology diffusion. Licensing just means that I license my know-how. So maybe there's a company in Vietnam that wants to license my technology. I can do that for a fee. Reverse engineering means taking things apart. So I can buy a fighter jet, I can dismantle the fighter jet, I can figure out how the fighter jet is made, and I can reproduce that. And of course, the internet is a great way to spread knowledge. You can find out how to do all kinds of things through open source technology. The democratization of the internet has really led to a lot of technology diffusion. Diffusion rates are getting faster. Telephones are a good example of this. When telephones were first invented in 1876, it took over 100 years for everyone to get a landline. Modern technology needs a whole lot less infrastructure. So for example, it took 100 years to get landlines diffused, but it only took 15 years to get mobile phones diffused, and it's only taken 8 years for smartphones to become common. So these things have really increased in terms of speed, of how long it took things. And a lot of those early innovations, like running water, also took 100 years. A lot of those took a long time because they required a lot of infrastructure, and modern technology diffusion does not require that kind of heavy infrastructure. Our last topic for this discussion is the future of work. So the labor market is changing, and it's changing because of technology. It's changing because of population aging. We talked about that in week 11. It's changing because of globalization. We've been talking about that quite a lot. Other things like the mitigation of climate change, things we will have to do to mitigate climate change, are going to disrupt the labor market. All of these changes are going to be potentially disruptive and difficult. There's very high anxiety in the labor markets over artificial intelligence and robotics and what that's going to do to our labor market. But I just want to point out that these fears are not new. In 1931, John Maynard Keynes, we talked about Keynesian economics, he warned then of a new category of unemployment called technological unemployment, of people who are put out of jobs because of technology. In the 1960s, Kennedy created an Office of Automation, and its goal was to maintain full employment at a time when automation was replacing workers. So, this fear of robots coming and taking our jobs is certainly not new. And in the 30s and the 60s, employment has continued to expand. So we'll see what happens this time around. Some people claim that this time around is different. Regardless of whether we all are put out of work by robots or not, there will definitely be a lot of job transformations and job transitions. And so managing those transitions effectively, providing training and re-education for displaced workers is going to be very important. The quality of jobs is also going to be at risk. It's pointed out, you're going to watch a video for an exercise in the next slide, and the video points out that robots are better, or AI is better at coming up with legal briefs than it is at sweeping the floor. So that might mean we're going to be the ones stuck sweeping the floor. Job stability is also at risk. We're seeing this front and center with the coronavirus. We've had this rise of employees in the gig economy. Those are Uber drivers and delivery people and things like that. And we'll see, and we can see during the coronavirus, the problems of the gig economy in that there's no unemployment benefits, no healthcare benefits for these employees. So what do you do with that? So we'll have to work that out. Labor market inequities will rise potentially. We're going to have more job losses in certain sectors and certain regions. We have to figure out how to deal with that. And our sources of comparative advantage globally could shift. Historically, it's been a source of comparative advantage if you have a young, cheap labor force. But with more AI and more robotics, that may no longer be the case. We've also talked earlier in the course about shifts in global supply chains because of AI and because of technology. And again, that could change a lot of the way we do business. So what's going to be required? Well, there's going to be some serious structural change. And that is going to require some coordinated policy responses, not only within our own country, but globally speaking. So your last activity for this particular week's lectures is to log off of here and watch this video. I'll put the link in your announcements so you can actually have the direct link. And as you're watching the video, it's about 15 minutes, but it's really, really good. I think you'll enjoy it. And I want you to jot down 3 new things you learned, 2 things you'd like to hear more about, and 1 question you have about the material. Thank you for listening to these 2 lectures about innovation, technology, and the future of work.